section, we will learn how to solve systems of linear equations by substitution. We will learn how to solve special systems, and we will learn how to solve systems with fractions and decimals. In the last section, we learned how to solve linear systems by graphing. But that method, as I mentioned before, has a problem that sometimes it's not easy. Most of the time, actually, it's not easy to determine the solution from the graph. You can estimate it, but you cannot be as accurate as you would need. For instance, if you want to solve this system, you graph the first equation, it's the blue one, graph the second equation, the red one. This is the intersection. It's difficult to read the x value. It's more than 3, less than 4, closer to 4 than 3, and so on. Similarly with the y value, it's somewhere between 0 and -1. We want a method that gives us the solution up to the accuracy we want. And this method is the substitution method. Basically, the method works by finding one of the variables in terms of the other and substituting that in the other equation. Okay, so we use one equation to find y in terms of x or x in terms of y. We substitute that into the other equation, and the other equation now is an equation with one variable, and we can solve that equation for that variable and return to the other equation to find the other variable. For instance, if you have this system of equations, the second equation already gives us x in terms of y. Okay, so this is an easy system to solve. So if the second equation was this, so what we do is we solve x for y as we have it over here. Okay, so the second equation gives us x in terms of y. We use that in the first equation to solve for y. So we have y, then we go back to this equation to find x. So let's see how that works. We use equation 2 in equation 1. 2 times x, okay, so this is equation 1. 2 times x, x according to equation 2 is -2y, plus 7y equals -12. So as you can see now, equation 1 is an equation that has only one variable, y, and it's easy to solve for y. So -4y plus 7 equals -12, 3y equals -12, y equals -12 over 3. We use equation 2 to find x. So x is -2 times y. So x is 8. The solution is 8 minus 4. Solution per order per is 8 minus 4. So this is the summary of the method as I explained it. Solve the system by substitution. It's easier to use equation 1 and find x in terms of y. So equation 1 gives x equals -4y minus 1. Use that in equation 2. So from 2 we get 2 times x, 2 times x minus 5y equals 11, expand, and we have minus 8y minus 2 minus 5y equals 11. So minus 13y equals 13, which means y equals minus 1. Then we use this equation to get x. So x equals minus 4 times y minus 1, 5 equals 4 minus 1 equals 3. So the solution is the order per 3 minus 1. And this system, we are already given, the first equation already gives us y in terms of x. So from equation 1, we have y equals 8x plus 4. So we use 1 in equation 2, 16 times x minus 2 times y. Y, according to equation 1, is 8x plus 4. Sorry, this is, okay, equals, the right side is 8. 16x minus 16x minus 4 minus 8, okay, minus 2 times 4 minus 8 equals 8. 16x cancels 16x, and the result is minus 8 equals 8, which is a contradiction. So you cannot find any x or any y that satisfy this system. This system has no solution. This system has no solution. The solution is inconsistent. Inconsistent. The solution has phi, the set phi. The set of solutions is the set phi, the empty set. Okay, we use equation 1 to find x in terms of y. It's easy because x doesn't have a coefficient. This is just for convenience. You can use equation 1 to find y in terms of x and use that in equation 2. You can do the same thing. You can find x or y in equation 2 and use that in equation 1. Doesn't matter. Okay. But some choices, usually some choices are easier than the others. So from equation 1, x equals minus 7 minus 3y. Use that in equation 2. So 4 times x plus 12y equals minus 28. Expanding, 4 times 7, 28, 4 times 12, 4 times 3 is 12, plus 12y equals minus 28. These are cancelled, and the result is minus 28 equals minus 28, which is correct without any conditions. It is always correct, which means any x, any y satisfies this equation. So any pair that satisfies one of these two equations any ordered pair that satisfies any one of these two equations is a solution. So you have infinitely many solutions. And the reason is that if you multiply equation 1 4 times equation 1, what do you get? 4 times x, 4 times 3y equals 4 times minus 7. So you get equation 2. So equation 2 is simply equation 1 in disguise. Okay? Because if you multiply an equation by a constant, multiply the right side and the left side of the equation by the same non-zero constant, you do not change the equation. You do not change the nature of the solutions of the equation. You still have the same solution set. We call them equivalent equations. So we have infinitely many solutions. Okay, and we say that the solution set is the set of all xy such that xy satisfy this condition. Okay, this condition, which is equation 1, is simpler than equation 2, and that's why we use it. Systems with fractional coefficients. Equation 1, equation 2. Now, if you multiply equation 1 by the common denominator, 2 and 3, least common denominator is 6. Okay, so 6 times equation 1 will give 6 times half x. 6 over 2 is 3. So 6 over 2x plus 6 over 3y. Don't forget to multiply the right side, 6 over 3. Now the second equation, to get rid of the fraction 2, you only need to multiply by 2. So 2 times the second equation. So it's 2 times half x plus 2 times 2y equals 2 times minus 2. So 6 over 2 is 3. You get 3x. 6 over 3 is 2. You get 2y. 6 over 3 is 2. Minus 6 over 3 minus 2. This is x. And 4y equals minus 4. So equations 1 and 2 are equivalent to these two equations. We call this 1, if you like, 1 prime, and this is 2 prime. Maybe it's better to use Roman numerals for equations. Okay, this is an equivalent system. This system is equivalent to this system, meaning it has the same solution set. They have the same solutions. They are logically, mathematically equivalent. Now, using equation 2 prime, we can find x equals minus 4 minus 4y. Use that in 1 prime. So 3 times x, this is equation 1 prime, 3 times x plus 2y equals minus 2. 3 times minus 4, 3 times minus 4 plus 2y equals minus 2. Minus 12y plus 2y is minus 10y equals minus 2. Take this to the other side, becomes plus. Minus 2 plus 12 is 10. So y equals minus 1. From equation 1, from this equation, okay, we find x. X is minus 4 times y. So this is equal to minus 4 plus 4, which is 0. So the solution set is the set that has only one ordered pair. Okay, we have a unique solution. One solution. Decimals, we do the same thing. We have one decimal. Okay, maximum number of decimals is 1. So we multiply both equations by 10. Okay, so this is equation 1. This is equation 2. Multiply both equations by 10. And by both equations, I mean the right side and the left side of the equations. So 10 times 0.2 is 2x. 10 times 1.2 is 12y. Never forget to multiply the right side. 10 times minus 1 is minus 10. So that's equation 1. Equation, so let's call this 1 prime. Equation 2, 10 times 0.1 is 1. So that's x, plus 10 times 0.3 is 3y equals 10 times 0.1 is 1. And that's equation 2 prime. Now we solve as before. Equation 2 prime gives x in terms of y. So x is 1 minus 3y. Use that in equation 1 prime. 2 times x. X is 1 minus 3y plus 12y equals minus 10. So now we have an equation with only one variable. Expand. Minus 6y plus 12y is 6y. Minus 10, take the minus, the 2 to the other side becomes minus 2. So minus 10 minus 2 is minus 12, which means y is minus 2. And we use this to find x. Okay. X equals 1 minus 3 times y. 1 minus times minus is plus, so 1 plus 6 is 7. So the solution is, the solution pair is x is 7, y is minus 2. Here we can say that implies x equals 7. Okay, so this is the solution. This is the ordered pair that is a solution to this system. Okay, we already did that.